Hello, Integrated Math 1 students. We are going to go ahead and finish up our examples that we left behind in class on Tuesday. Really quick, before we get started on that, I just want to remind you of our two exponent rules that we learned in class that day. Exponent rule number 1 is any base to the 0 power is equal to 1. I don't care what that base is. And remember, the base is the big number. I don't care what it is. If I have a 0 exponent, the answer is 1. My second rule is that if I have a negative exponent in order to make it positive, I take the reciprocal with the base and I change the sign. If that exponent is negative in the denominator, to make it positive, I bring it to the numerator. So basically what happens is we flip it and make it positive. Sorry, the area's going the wrong way. This is technically over 1. We bring it down, make it positive, or bring it up, make it positive. Those were our two big rules we learned. All right, so let's look at this. Number 8. My advice to you is if you feel like you know what you're doing, go ahead and try these on your own and then check your answers. If you feel like you need a little bit more help, then you can just go ahead and follow along, okay? All right, x to the negative first power. All right, remember, in order to make an exponent positive, we need to take the reciprocal and then change the sign. So x to the negative first is technically over 1. In order to make it positive, what we're going to do is we are going to take the reciprocal, so flip it, and change the sign. So the answer to this question would be 1 over x to the positive first. We don't need an exponent of positive 1. We're too lazy to write it, so the answer is just 1 over x. All right, number 9. Negative x to the negative first. What this looks like is, remember we talked about today in class, this exponent only belongs to its base. So if I were to write this out, this is actually negative 1 times x to the negative first power. So only this base x has a negative exponent. So how I can write this is I leave the negative 1 on top. This x to the negative first is technically over 1, and in order to make it positive, I flip it and make the exponent positive, times 1 over x to the positive first. We multiply across negative 1 times 1 is equal to negative 1. 1 times x to the first is just x to the first. And remember, when we have the parentheses, this entire base belongs to the negative first power. So we're going to remember that this whole thing is over 1. And in order to make it positive, what we need to do is move it to the bottom and change the sign of the exponent. So what we would have is we would have 1 over negative x to the positive first, which is just 1 over negative x. So remember, parentheses matter. They tell us whether that negative sign belongs to the base or not. This negative sign belongs to the base and the exponent. This negative sign is on its own, a negative 1 in front that we need to pay attention to. All right. If I were you, I would pause this video right now and do 11, 12, and 13 on your own, and then come back and check your answers. All right, number 11. 3 to the negative second power. Remember, this is over 1. So in order to make it positive, what do? We take the reciprocal, we flip it, right? And we change that exponent to become positive. So this would be 1 over 3 to the positive second. Well, 3 to the positive second is the same as 3 times 3. So this is the same as 1 over 9. All right, number 12. that negative 2 only belongs to the 3. 5 is on its own. So I've got that negative 2 being over, that 3 to the negative second being over 1. In order to deal with this, I take the reciprocal and I change the sign of the negative exponent. That 5 stays where it's at. 5 times 1 over 3 to the positive second. All right, so this is 5 over 3 to the second, which is the same as 5 over 3 times 3, which is 5 over 9. Okay, let's keep on going. Over here, this negative sign belongs to the base and the exponent. So this whole entire thing is belonging to that exponent. It's over a base of 1. In order to deal with this, I take the reciprocal and change the sign of the exponent. That negative 5 is on its own in the front. Negative 5 times reciprocal 1 over negative 3 to the positive second power. This is the same as negative 5 over negative 3 times negative 3. See how that negative sign belongs to the exponent, so I'm multiplying negative 3 by itself? Okay, well, this is the same as negative 5 over negative 3 times negative 3 is a positive 9. So those parentheses make a big difference. See how over here we got a positive 5 over 9, over here we got a negative 5 over 9. Those parentheses tell us where that negative 1 goes. Is it on its own in front, or does it belong to the base and the exponent? All right, let's try number 14. When we have these problems, what we want to do is we want to kind of take them step by step, okay? So let's do that. I notice right off the bat, I have an x to the 0 power, and I know that that is 1. So I can just make that 1 right away. 4 times 1 over y to the negative 3. 4 times 1 is just 4 over y to the negative 3. Now, you only want to deal with bases attached to a negative exponent. So I'm only going to look at this situation here, and it's negative. So what do I do to make it positive? I'm going to bring it to the numerator and change the sign. I don't do anything with the 4 at all. The 4 stays exactly where it's at. And my answer is 4y to the third. If you have a negative exponent, in order to make it positive, you flip it. If it's in the bottom, bring it to the top and make it positive. If it's in the top, bring it to the bottom and make it positive. Either way, you flip it and change the sign. Number 15. All right, let's kind of space these things out here. I have no parentheses on top, so this is technically a negative 1 times 5 to the 0 over 2 to the negative 2. I'm going to start off with the easy things first. I notice I have a 5 to the 0 power, which is 1. So I'm going to break this down and say that on top I've got a negative 1 times 1 over 2 to the negative 2. Negative 1 times 1 is negative 1 over 2 to the negative second. This is a negative exponent. In order to make it positive, I'm going to have to move the entire thing to the top and change the sign. I don't need to do anything to that negative 1 because it doesn't have a negative exponent. So negative 1 is chilling there by itself. And now 2 to the positive second comes along also. Remember, 2 to the positive second is the same as 2 times 2, which is 4. So now I have negative 1 times 4, which is negative 4. All right, number 16, x to the second over y to the negative third. Y to the negative third is the issue here. It's got a negative exponent. In order to make it positive, I'm going to bring it to the top and change the sign. X to the negative second is not x to the positive second is not a problem because there's no negative exponent. So it stays where it's at. Leave it alone. So x to the second times y to the third. There's nothing else I can do after that. Everybody's positive. So we are good. Last one. I've got two negative exponents here. So I've got x to the negative, x to the negative second as one, and then y to the negative third as the other. In order to make that x to the negative second positive, I got to bring it to the denominator and change the sign. So let's do that. 8 isn't hurting anybody. It sees where it's at. 8 over x to the positive second, y to the negative third. Y is still a problem because it's still negative. So in order to fix that, we're going to bring y to the top and change its sign. Nothing happens with 8, nothing happens with x. Everyone has positive exponents, we're good. 8y to the third over x to the second. All right, so remember, if we're simplifying, that means we want no negative exponents or 0 exponents. When we're solving these things, we want to space things out or separate things, separate our terms by multiplication, so we can identify the base. I need to know, what is my base? My base here is y. My base here is -5, or positive 5, not a -5. You want to separate these things out so that you can see where the exponent belongs. And then remember, if your exponent is negative, you're just going to move it so it becomes positive. Move it so it becomes positive. Move it so it becomes positive. If it's negative in the numerator, bring it down. If it's negative in the denominator, bring it up. I don't expect you to get these things overnight, but I want you guys to try and give it your best effort. Please submit this document completed to the Canvas link, and I will see you in class on Friday. Bye.